Today we are going to learn about Bellman-Ford algorithm. So Bellman-Ford algorithm is a single shortest path algorithm where it finds the shortest distances from one vertex to all other vertices in the graph. But unlike Decotter algorithm also does such thing, but unlike Decotter algorithm, we can put negative edges in a graph. But another precondition of using Bellman-Ford algorithm that it should not contain a negative weight cycle that is reachable from the source vertex. So this is the algorithm of Bellman-Ford, where we initialize the graph where the source distance vector is kept at 0 and all other distance vectors for all other vertices are kept at infinity. Finally, this algorithm, there are two for loops. So basically it's a big O of n square algorithm, where we see the first for loop runs for n1 to n minus 1 vertices, that is vertices minus 1. So if there are 5 vertices, it runs for the 4 times. That inside that for each edge and the weight, the algorithm will decide the distance vector of particular node, where if there is a source and destination vertex, and if there is a source and vertex weight plus the weight of the edge is lesser than the distance vector of the destination vertex, then the destination vertex weight is changed by distance vector weight plus the edge weight between the source and the destination vector. So in this way, this algorithm works repeatedly for vertices minus 1, that is for the number of vertices times, and it stabilizes the distance vectors of all the vertices. We will take a simple example to understand that. In the state tree, lastly, we see that the negative, if I try to find out the negative weight cycle. So if there is a negative weight cycles, the algorithm is basically failed. So initially what we see, there are 5 vertices in serial order, that is A, B, C, D, E. So we see that initially A is made, the source vertex is 0 and all other distance vectors are kept at infinity. In the second stage, we will see that for the 4 iterations, we see for each edge we are applying the algorithm, that is, if the initial distance plus weight, if it is lesser than the distance of the final vertex or the destination vertex, then the distance of the final vertex is changed by distance of the initial plus weight between the initial and the destination vertex. So we see between A and B, if it is minus 3, so 0 plus minus 3 is minus 3. Minus 3 is less than infinity, so B's distance vector becomes minus 3. Now between B and C, it is weight, it is 1, and minus 3 plus 1 is minus 2. Minus 2 is less than infinity, so value becomes minus 2. Similarly for D, minus 2 plus 1 is minus 1 is less than infinity, so this value becomes minus 1. For E, minus 1 plus 1 is 0, so 0 is less than infinity, so E becomes 0. But this process has to be repeated 4 times over to finally stabilize all the distance vector of all the vertices. So we take an example of 5 vertices into case where there is a source vertex S and there are other 4 vertices, that is A, C, B, D. So initially we apply from S to A and S to B. So and we find that A's value is 0 plus 3 and infinity, between infinity and 3, the A's value becomes 3. For B it is 2, between 2 and infinity. So 2 is lesser, so this value becomes 2. We apply A to C and B to D. We find that C's value changes from 3 plus 1, that is 4 and infinity. The value C becomes is 4, and this value becomes 2 plus 1, that is 3, and infinity value, this value becomes 3. Now we apply other edges, that is B to A and A to C. Now we see A's value again changes between 2 minus 2, that is 0, and 3 to select obviously 0. For C it becomes between 1 and 4, so C's value becomes 1. Finally, for this value, we see that this value between 3 and 2, the value becomes 2. So finally, we reach the conclusion, the final answer. So this is your assignment, complete in time.